Hi, I'd like to show you a little few things about inequalities, what they're all about. And first off, an inequality is really just these alligator signs. If you remember, probably back in elementary school, you saw something like this, uh, like this, and you had a statement. Let me move this down a little bit, and you had a statement, something like 2 is less than 5. So this is this is the less than inequality. Then we could have something like 8 is greater than 1. So this is the greater than inequality. But now we can also do something else. We could have we could have this. This is called less than or equal to. And, well, you might guess it. This one would be greater than or equal to. And the way we use this is we will solve inequalities. For instance, I'll move this over here, and let's say I have some number. I'll call it x, and that x is greater than or equal to 2. Okay, so what numbers would fit in for x? And so our solution set, because it's not just one number. I mean, yeah, of course we could have, and they put these in these curly braces here. We could have 2. Isn't 2 greater than or equal to 2? Because we're trying to make sure that we can put this number in for x. We can substitute it in here. And 2 is greater than or equal to 2. It's equal to 2, so it fits. And then what else could we do? We could have 3. Right? I'll put a little space. 3. We could have 4. And any number greater than that, that is our solution set. I could have, on the other side, I could have x, any number, is less than 10. And our solution set, well, it couldn't be 10. The biggest number we can get would be 9. And we could have maybe 8. We could also have 7.5, any decimal, right? We could have a 1/2 is smaller than 10. We can have any negative number, -4, and so on. So how many answers are there? There are an infinite number of solutions to these inequalities. And that's different. That's different than something like, I'm going to move this over here. That's different than something like if I have x is equal to 2. Well, what is the solution set? Well, it's just 2. Not that exciting. But in inequalities, you can have an infinite number of answers. But not every number is your answer, right? So, because what I could do is I could go here, and if I'm looking at this, could I put a number, well, could I put the number 1? 1 won't work. 1 is not part of our solution set, so I'm not going to include that. Or 11 in this one. 11 is not less than 10, so it's not part of my solution set, yet I still have an infinite number of solutions. And what we do is we will also graph these solution sets. So what we'll do is we'll do it on a number line. And I will draw a beautiful number line right now. And what I do is I usually have 0 here, and then 2 is over here. And the solution set to this is I will have a closed dot. So I'm talking about, okay, I'm starting at 2, and I'm talking about the numbers greater than 2 or equal to. So equal to, there's the dot. The colored dot shows it's equal to 2, and it's greater than. So I have an arrow. And we can graph this one too. I'm going to cheat a little bit. I have 0, and then I have a whole bunch of others here, and then somewhere over here I'll have 10. And I'm talking about the numbers less than 10. So that's called an open dot because I'm not including 10 in my solution set. But the numbers less than 10, they go in this direction because the numbers get smaller going to the left. And that's how that pretty much works. So to take it further, instead of just graphing these inequalities, we could also graph or solve and graph one-step inequalities, such as this. I might have x plus 2 is less than negative 4. Okay, now to solve this, I would solve it just like I would solve x plus 2 is equal to negative 4, where I would use inverse operations. If I'm adding 2, I would subtract 2, and I have x is equal to negative 6. Okay, so what this means is the only number that will work is negative 6. Because if I put negative 6 in for x, negative 6 plus 2 is equal to negative 4. So this is said to be the solution. Solution to the equation. Now for the inequality, it works the same way. I would subtract 2, and I have x is less than negative 6. So now I have x is less than negative 6. So there is the solution right there. It works the exact same way. But now if I'm going to graph this, I would have 0 here, and negative 6 is somewhere to the left of that, and it's going to be an open dot because I'm not including negative 6, but the numbers less than negative 6 go to the left, right there. Now, if I were to graph this one, by the way, I would have the same 0 and the same negative 6, but it's equal to negative 6, so I would just put a dot on there. And there you go. That's how these work. I'll give you one more example where, oops, sorry, I meant to do that. Now, I could also have x divided by 4 is probably less than or equal to 3. And I could have x over 4 is equal to 3. So to solve this equation on this side, since this is division, I would multiply these two together. Again, I'm trying to figure out what is the value of x. What number divided by 4 is 3? Well, I could multiply these two together, and x is equal to 3 times 4, which is 12. And isn't that true? Isn't 12, 12 divided by 4, yeah, that is equal to 3. And we would do the same thing for this one. We would have x is less than or equal to 3 times 4. So it's this exact same thing going on. And we have x is less than or equal to 12. That is not as nice as I want it to be. That'll work, I guess. So that's right there. So there you go. These are some basic ideas of inequalities and what they mean and what are they doing. And that's it. Thanks for watching.